All right, so welcome to the video lecture series on Introduction to Computer Networks. And today's topic is going to be the Internet and specifically the architecture of the Internet. So the Internet structure overall, we can refer to it as a large-scale network of networks. One of the main things that we see in today's internet structures are the presence of what we call internet service providers, or in short ISPs, and they are responsible for providing users the actual connection um, to the network of networks, what we call as the internet. So as a result, we must say that the ISPs must be connected to the larger network with other ISPs, which forms the overall global internet. However, on the other end, it also allows end terminals to connect to these ISPs and eventually be able to send packets to other terminals which are connected to the global internet. So eventually, the resulting network of networks, which form the overall internet, is very complex. And over time, we have seen that the general evolution of the internet has been primarily driven by a lot of financial and economical reasons, in addition to various national policies. For example, there are certain countries which have very high very strict privacy policies. On the other hand, there are countries which have considerably lenient privacy policies, etc. So the internet has seen a lot of evolution over the years, over the past few decades, and everything is driven definitely by the evolution of technology. But however, alongside economics and national policies play a very important role in the definition of the overall internet structure. So let's consider the basic development process of the internet. So the first very primitive solution to create a large-scale network of networks would be to have them all interconnected. So the solution is basically to connect all the ISPs to one another, and the eventual result would be a full-scale, full mesh network. So if we go into the number of connections which are required, so let's assume there are n number of ISPs on the internet. So therefore, the nth ISP will require n minus 1 number of connections to connect to the remaining n minus 1 ISPs. The n minus 1th ISP will require n minus 2 connections to connect to the remaining n minus 2 number of ISPs, and so on and so forth. And if we do a mathematical summation, it's basically n minus 1 plus n minus 2 plus n minus 3, so on to onwards to plus 2 and plus 1. And this is a geometric summation formula, which is equals to n multiplied by n minus 1 divided by 2 number of connections to create this large scale internet which is fully connected. And definitely, as you can see, this is definitely not a scalable solution. So let's see what we can do in a better approach. So we can say that the first requirement is that the millions of global ISPs we have all over the world, all of them need to be interconnected. So a better solution than the previous one would be to connect all the ISPs to one single global ISP, which is very similar to a hub and spoke model that we have seen earlier for wide area networks. So the required conditions would be to have financial contracts between customer ISPs and the provider ISP. The customer ISPs are the small scale ISPs which are connecting to the global ISP, and the provider ISP is the large ISP which basically connects all these smaller ISPs in the hub and spoke model. So this eventually will create a business monopoly, and definitely this is not financially feasible. right? Even if this is technically feasible, this might not be a very good financially feasible solution. So let's see what we can do further as a further improvement. So the basic core requirement stays the same, that we want all of the global ISPs, which are millions in number, and all of them to be interconnected. So instead of having one global scale ISP, we can have multiple global scale ISPs which connect these smaller ISPs together. And the large ISPs, which are the global ISPs, they are connected to one another, right? And what happens is that we are distributing the monopoly market, which we saw in the previous solution, and also we are creating this hierarchical organization. In terms of the connections, the large ISPs can be connected to each other directly. We call these peering links. That means two global ISPs can be connected directly as peers, or they can be connected through something that we call Internet Exchange Points, or IXP. So these Internet Exchange Points are basically cable connectors, servers, or providers who provide the connections between the global scale ISPs to be able to communicate to each other. So the smaller ISPs connect to the global scale ISPs, like leaves all around the internet, and the global scale ISPs are all connected to each other through the peering links, that is the direct connections, or through the internet exchange points. So the resulting structure is basically a decentralized hub and spoke model, and this is the modern structure of our current internet. So if we look at a simplified model of the internet with what we have seen to be the structure so far, the current internet is formed with a lot of these ISPs, which we call as access nets, and these are all located in different regions, and they are connected to a network of global scale ISPs. The global scale ISPs, they are much large scale providers working across continents and countries, and they are a separate network connecting the other smaller ISPs. There's also something that we can refer to as regional networks. So these regional networks are kind of like a mid-tier management network to connect multiple access points in a given region. So let's say we can say that the east coast of North America can be a regional network connecting all the access nets, which are the smaller ISPs, into one regional network, and multiple regional networks, for example, the East Coast, Central, Midwest, Western, all of these regional networks could be connected all together with the help of global scale ISPs. And eventually, the global ISPs are connected to each other through peering links that are, those are the direct connections between the two global scale ISPs, or through the internet exchange points, which are dedicated providers of connection between two global ISPs.